Good evening, class 11. So let's continue with the part. Last class I stopped at atomic radius, okay, at the periodic variation of the atomic radius. So today we'll be doing the variations about the ionic radius. So ionic radius, last class we did this, that here the internuclear distance is equal to internuclear distance is equal to radius of cation plus radius of anion. Okay, this we did in the last class. Now, other than this, we have some more informations. First one, cation much smaller in size, much smaller than their parent atom. Much smaller than parent atom. So, let's take an example. Example, if I take sodium, it loses one electron, so I get sodium positive, right? So this is my cation, this is my parent atom. Now, here the number of electron is how much? 11. Here the number of electron is 10 because one is lost. Number of proton is 11. Number of proton is 11 here as well. Now, since the number of proton in case of Na positive, that is cation, is much more than the number of electrons, so the effective nuclear charge is more in case of Na positive. As the effective nuclear charge is more, so the nuclear pull on the outermost shell is much more. As a result, the shrinking of the atom is more, or shrinking of the ion is more. That's why cations are smaller in size. Since the number of protons is more than the number of electrons, effective nuclear charge is more. As a result, nucleus pulls the outermost shell very strongly, and so its size decreases. That's why cations are much smaller than their parent atom. Now, if I change this, if I write anion, then it will be the exact opposite. It will be much larger than the parent atom. For example, if I take chlorine atom and chloride ion, Cl, 1 electron gives you Cl minus. In case of Cl, number of electron is 17, proton is 17. In case of Cl minus, number of electron is 1 more, so 18 electrons, and proton is your 17. So since here the number of electron is increasing, okay, and proton is remaining the same, that means what happens? The effective nuclear charge on each electron will be lesser, because here the number of electron has increased, right? So effective nuclear charge per electron will be lesser. Effective nuclear charge is represented as Z star. Effective nuclear charge per electron decreases. So what happens? It decreases. So the nuclear pull is lesser and the size is much more compared to the parent atom. This is the basic reason that anions are larger and cations are smaller than the parent atom. Okay. Now the trend. If I talk about the periodic trend, that is down a group and across a period, the trend is absolutely similar to that of atomic radius. That is, across a period or moving across a period, we know the effective nuclear charge increases. So my ionic radius will increase. Ionic radius will increase across a period. Down a group, regularly it is across a period, ionic radius will decrease. Down a group, what happens? We know new quantum shell is added, so ionic radius will be increasing. Across a period, what is happening? The effective nuclear charge across a period is increasing. So what happens? The nuclear pull is much more, so the radius will be decreasing. This was similar to the concept given by atomic radius variation. Group also, what happens? Down the group, the shells are added, new shells are added, so distance increases. As a result, the radius also increases. Same variation as that of atomic radius. Now we come to the next part under ionic radii, that is isoelectronic species. Isoelectronic species. Isoelectronic species. What are the meaning of isoelectronic species? The species that have similar electronic configuration. The ones with similar electronic configuration. They have same electronic configuration, but their protons will vary, that is the nuclear charge will be varying. So how to understand or how to measure their sizes? Not measure, how to talk about their increase and decrease in the sizes. For example, if I take N3 negative, O2 negative, F negative, then Na positive, Mg2 positive, Al3 positive. All these ions, all these anions and cations, they have the same electronic configuration, that is 2-8. 2-8 configuration, right? That means they have same number of electrons. They all have same number of electrons, that is 10. But their number of protons are not same. In case of nitrogen, what is the proton number? Proton number, nitrogen it is 7, oxygen it is 8. Okay, proton number means the atomic number. F it is 9, sodium it is 11, magnesium 12, aluminium it is 13. So we know the nuclear charge is basically the presence of these protons in the nucleus. So higher the number of protons, higher the effective nuclear charge, so lesser the size of the ions, right? Because for all these ions we have a fixed number of electrons, that is 10, right? Now with increase in the number of protons, the effective nuclear charge increases. As a result, the size of the ions decreases. Okay, so this effective nuclear charge, if we move across, that is from nitride to aluminium ion, if I move, then what happens? My effective nuclear charge increases, that is Z star increases. Okay, that means nuclear pull increases, so size decreases. Size will be decreasing, downward arrow. Z star increase and size will decrease. So this is the basic order in case of isoelectronic species. Okay, now the next one, next is your nomenclature of elements with atomic number greater than 100. Nomenclature of elements, atomic number greater than 100. Atomic number greater than 100. Here we will do a table. On that basis of table only you have to do the names. You have to give the names of the elements. First column, digits. Then second column you have the names. And third one, the abbreviation, means the short forms that you have to use. Digits we have 0 to 9. Okay, names, for 0 it is nil, for 1 it is un, 2 it is bi, 3 it's tri, 4 it's quart, 5 it's pent, 6 it is hex, 7 it is sept, 8 it is oct, 9 it is in. Abbreviation N, the first alphabet. Here U, B, for 3 it's T, 4 it's Q, 5 it's P, H, it is for 6, for S, for 7 it's S, 8 it's O, for 9 it's E. Basically the first alphabets we are going to use as the abbreviation. Now suppose we have an element with atomic number 105. And what is my name on the basis of this chart? 105 atomic number, what should be the name? So 1 it is un, 0 it is nil, then 5 we have pent, and will end it by IUM. So un, nil, pent, ium. Right? If I have 112, then it will be un, again un, or 2 it is bi, bium, un, bium. Okay, then if I have 117, then again un, sept, ium. So this way we have to name. These are the abbreviations. Okay, and this way we name. And if I write the short forms, we'll be writing U, first alphabet here, then your N, then P. Here also the first alphabet is U, then again U, then B. In case of 117 it is U, U, and this will be your S. So that's it. Okay, fine. So that's all, class. Thank you.